So here we are with our information. We're going to apply first a synthetic approach, putting together little pieces of information. That often seems to be the most natural thing for students, particularly when we begin studying this subject. So let's begin with the idea of average velocity. I know as this coffee bean falls toward the coffee can, it's going to speed up as gravity pulls down on it. This should be intuitive, that as things fall, they speed up. So it's going to have some average speed that's higher than its initial speed. We know that the average speed of the coffee bean in the y direction is going to be its initial y speed plus its final y speed divided by 2. That's just how we average two numbers. And we're allowed to do this in the case of constant acceleration, which we'll talk about in more detail later. I also know that the average velocity in the y direction is simply how far I travel along y divided by how long it takes to travel that far. This is just the natural way of defining average velocity, how far you go divided by how long it takes to go that far. So I see that we have two numbers here that are equal to each other, and we can plug in. I know that the initial y velocity here is 0, so 0 plus Vy final over 2 is equal to how far we fall, which is negative 1.3 meters, divided by how long it takes to fall, which is t. So this shows us that Vy final is, multiplying both sides by 2 here, negative 2.6 over how long it takes that coffee bean to reach the coffee can. What other information do we know? We know that this coffee bean begins with no vertical speed as it leaves the horizontal table, but its speed is always going to increase. So Vy, as a function of time, is going to be how quickly it's accelerating, the acceleration due to gravity, times how much time is going by. So I know that my final Vy is going to be that acceleration due to gravity, which is negative 10 meters per second squared, times how long it has to fall, which we're calling t. So notice here that we have two expressions for Vy final. Vy final is negative 10t, and Vy final is also negative 2.6 over t. We can set these expressions equal to each other to see that Vy final is equal to both negative 10t and negative 2.6 over t, and solving for t here, I see that t squared is equal to 2.6 over 10, or t is equal to the square root of 0.26. That's how many seconds it takes to reach the coffee can with the bean. So now how far will we need to place the coffee can? Well, I know that how far the bean travels is how fast it's going times how long it goes that fast. And that's not changing because there's no force accelerating this bean horizontally. It's just going to retain that same horizontal speed. So this will be 4 meters per second times the square root of 0.26 seconds. Notice that 0.26 is very close to 0.25 or a quarter, and the square root of a quarter is a half. So 4 times a half, we know that this needs to be approximately 2 meters. So that is the synthetic approach for solving a problem like this. We'll return to this problem and solve it using the analytic method.